my beautiful listeners, welcome again to class. It is your favorite channel, BFN112 Mathematics class, and today we are going to be having a revision on matrices and determinants, especially for my students that are writing the exam on BFN112. Alright, so these videos will be on different subtopics, but particularly this particular video will be on, we shall be looking at, what's it called? Addition and subtraction. Okay, addition and subtraction of matrices, and then we're also going to be looking at multiplication. Okay, and then lastly we're going to be looking at transposition of matrices. So if this is the first time joining us, you're welcome to class again. Don't forget to subscribe and also help us share the video so it gets to other listeners. All right. So first of all, matrix can be spelled in two ways. We have matrix with ox, and then we have matrix with CE. Now this has to do with singular, all right, the matrix with the ox, and this has to do with the plural part of it. So now, how do you carry out addition and subtraction processes on matrices? So we're going to be very brief with few examples so that we can be very fast. Okay, let us begin. I'll give an example, but before I'll give the example, let us see. How can matrices be represented? We have different types of matrices. Matrices can be 2 by 2 matrix, 3 by 3 matrix, 2 by 1, 3 by 1. It depends on how the elements are being arranged. For instance, if I have A is equal to 2, 4, 1, 3, 2, 3. All right. This type of a matrix is known as a 2 by 3 matrix. Why? Because I have two rows, all right? Row 1, row 2, and then I have 3 columns, all right? So this is row 1, this is row 2, this is column 1, column 2, and column 3. Now mind you, when you are pronouncing, make sure you pronounce the rows, okay, before you pronounce the column. So I have a 2 by 3 matrix. What if I have something like this? B is equal to 4, 1, 3, 2, 4, 1. What kind of matrix is this? Now, this is row 1, and this is row 2, and this is row 3. Alright, now this is column 1, and this is column 2. So if you count the number of rows, we have 3. And then when you count the number of columns, we have 2. So this is called a 3 by 2 matrix. All right. Now, all these numbers inside this matrix are known as elements of a matrix. Now, these elements of a matrix are arranged in two ways. One, in columns, and then in rows. Rows are the horizontal. All right. These are the rows. And the columns are the vertical. All right. These are the vertical, which are the columns. So now, the next question we're going to be looking at now is how we can carry out addition and subtraction on matrices. All right. So let's see the first example. Example 1 says, if matrix A is equal to 2, 4, 1, 3, and matrix B is equal to 3, 6, 1, 4. Okay, now find. All right, number 1, matrix A plus B. Okay, number 2, 3A minus B. All right, so let's just work with this. Okay, these two examples. With this example, I bet you'll be able to understand how it works. All right, now, first of all, matrix A is a 2 by 2 matrix because we have 2 rows and then we have 2 columns. And also with matrix B, 2 by 2 matrix. So we are told here now to add. So it simply means we are adding all the elements in matrix A and all the elements in matrix B together for us to get A plus B. So it's very simple. Let's go. Solution. Now A plus B becomes, okay, the matrix of A, which is 2, 4, 1, and 3. Okay. Now don't forget the sign we have here is plus, so we're going to give a plus side here. Plus the matrix of B, which is 3, 6, 1, and 4. Right. So if we should do that, this is how it works. Okay. Now The first number here, the first element here rather, is added to the first element here in the second matrix. So 2 plus 3 gives us 5. Alright. And then 4 plus 6 gives us 10. Okay? And then 1 plus 1 gives us 2. And then 3 plus 4 gives us 7. You see, this becomes our answer. 5, 10, 2, and 7. The answer is also in 2 by 2 matrix. Okay. So let's go to question number 2. Question number 2 says 3a minus b. Now the difference between question 1 and question 2 is this. In question 1, a here has a coefficient of 1. Alright. But in question 2, a has a coefficient of 3. And we all know that 3a simply means 3 times a. So it simply means that 3 will multiply all the elements in matrix A before we subtract matrix B from it. So let's arrange it. It becomes 3 into the matrix of elements of A is 2, 4, 1, 3. Okay, now we have our minus sign. So here becomes minus. Now B becomes 3, 6, 1, and 4. So here it is wrong to say 2 minus 3, just like that is wrong. Why? Because our matrix A is carrying a number outside, which is 3. So first of all, we have to use this 3 to multiply everything inside the matrix of A. So if we should do that, we're going to get this. Now 3 multiplied by 2 gives us 6, 3 multiplied by 4 gives us 12, 3 multiplied by 1 gives us 3, and 3 multiplied by 3 gives us 9. Right. Now minus, here we have 3, 6, okay, 1 and 4. Again, no more number here, no more number here. So now we can subtract. So class, when we subtract, we'll be getting this. 6 minus 3 gives us 3. 12 minus 6 gives us 6. 3 minus 1 gives us 2. And lastly, 9 minus 4 gives us 5. So this becomes the answer to question number 2. So class, this is how you can carry out problems. Solve our problems on addition and subtraction of matrix. It's very, very, very easy. All right. So the next part we are going to be looking at is how we can carry out multiplication. Now, multiplication is somehow confusing, but that doesn't mean it is difficult. All right. So let's see the steps we can follow when carrying out multiplication processes on matrices. Okay. Don't forget, if you are just joining us, subscribe and also help share our videos. So let's go to multiplication now of matrices. So we are going to be taking our second example. And the question says, if the matrix of, okay, A equals to, let's use 2 by 2 first. 4, 3, 4, 1, and B equal to 1, 4, 3, 2. Okay. Find, let's say AB. Find AB. Now, AB means A times B. So it means here we're going to multiply the matrix of A by the matrix of B. How do we go about that? Let's see. Solution. So I'll come now. Here becomes AB is equal to the matrix of A, which is 4, 3, 4, 1. All right. Now, there is no need for me to put times here. What I just need to do is to bring my order matrix close to it. It means times already. When there's no sign there, when there's no sign between the two matrices, it means we are multiplying. So here becomes times 1, 4, 3, and 2. Okay. So now, this is how it works. Please observe. I have row 1 and I have row 2. So this is how we do it. Row 1 will multiply column 1 on the second matrix, and row 2 will also multiply column 1. All the rows in the first matrix must multiply the first column in the second matrix. Okay, so if we do that, we're going to get this now. Let's see. Now, my first number in row 1 is 4. So 4 will multiply the first number in column 1 in the second matrix. Now 4 times 1 gives us 4 plus. Now my other number now in row 1 is 3. Then the down number in column 1 is 3. So now 3 more multiply 3. So 3 times 3 gives us 9. It's as simple as that. 4 multiply 1, 3 multiply 3. So the first row has multiplied the first column. Now let's go to the second row now, which is this 4 1. Again, the way we multiply the first one with the first column, we're also going to multiply it again the same way. So here becomes 4 times 1, and here becomes 1 times 3. So 4 times 1 gives us 4, plus 1 times 3 gives us 3. So we are done with the first column. All right, we are done with the first column. So now we'll go to the second column. Everything that happened here will happen again, but this time with 4 and 2, which is the second column. So we'll go now. 4 will multiply 4 to give me 16, plus 3 now will multiply 2 to give me 6. We'd have no business with 1 and 3 anymore. We are done with 1 and 3. Now, again, to get the second, what's it called? The row here. Now we're going to use the down row here. Now 4 will multiply 4 again now to give me 16. And then 1 will multiply 2 to give me 2. Alright. So when we do that, let's add. Here becomes 4 plus 9, which is 13. And 16 plus 6, which is 22. And 4 plus 16, which is 20. And 3, that was a mistake. 4 plus 3, which is 7. And 16 plus 2, which is 18. So our answer becomes 13, 22, 7, and 18. This is how it works, 2 by 2 matrix. Now the next example we're going to be looking at is how can we multiply a 3 by 3 matrix? The same process, nothing changes. Or the first row multiply the first column, the second row multiply the first column, just the same procedure. Okay, but we're going to give an example here to make things easier for us to understand. All right, for us to understand. But let's go to the next question, the next example rather. Okay, which gives us example 3. Example 3 says, all right, if matrix of A, let's be fast, is equal to, let's use this, 3, 1, 0, 1, 2, 1, 1, 4, 2. All right, and B is equal to, okay, let's say 2 minus 1, 3, 4, 2 minus 2, 1, 0, 1. Okay, fine. AB. Find AB. Again, AB means A times B, which is the matrix of A times the matrix of B. But now we are working with a 3 by 3 matrix. It doesn't change anything, okay? It doesn't change anything. So let's see what we can do now. Solution. Now AB becomes the matrix of A, 3, 1, 0, 1, 2, 1, 1, 4, 2. Like I said, no need for sign, no need for times, just put them close to each other. Matrix of B, 2 minus 1, 3, 4, 2 minus 2, 1, 0, 1. So, it's not magical. It's just something you should understand. How do we go about it? The first row, multiply the first column. Second row, first column. Third row, first column. Everything here must multiply the first column before you move to the second column, and then before you move to the third column, which is actually the last column. So let's begin. Here becomes. Now, what do we do? The first number here is 3, the first here is 2. So 3 times 2 gives us 6, plus the next number is 1, the next number is 4. Like this, like this. It's just this pattern, just like this. Like this, multiply this. It's right. Horizontal, multiply, vertical. Simple. So now let's proceed. Call me. So let's go now. 3 multiplied 2 gives me 6, plus 1 multiplies 4 gives me 4, plus 0 multiply 1 gives me 0. Simple. It's that simple. Row, multiply, column. Simple. Now let's go to the next row. The next row is 1, 2, 1. Again, we multiply 2, 4, 1. So let's go. 1 multiplied 2 gives me 2. 1, sorry, now we're using this one now. We're no longer using this, we're using this. Now 2 multiplied 4 gives me 8. And 1 multiplied 1 gives me 1. We're done. Now let's go to the last row. The last row is 1, 4, 2. So let's go. 1 multiplied 2 gives me 2. 4 multiplied 4 gives me 16. And lastly, 2 multiplied 1 gives me 2. Yes, we are done with using the first row to the rows on matrix A to multiply the first column on matrix B. So what do we do next? We are done with this first column. Now we are going to what? Column 2. We will repeat the same thing. It's like repetition over and over again. So what do we do now? We begin again from the row 1. 3 multiply this multiply this multiply this. Because now we are using the second what? Column. So now 3 times minus 1 will give us what now? Minus 3 plus 1 times 2 gives us 2 plus 0 times 0 gives us 0. We are done with the first one. So what do we do now? Go to the next row again. Next row with this same one. So let's go now. 1 multiply minus 1 so gives us minus 1 plus 2 multiply 2 to give us 4. 1 multiply 0 to give us 0. Now we go to the last row with the same column. 1 multiply minus 1 to give us minus 1. 4 multiply 2 to give us 8. 2 multiply 0 to give us 0. Simple. Now we are left with just one column. We repeat again. We start from the first part, row 1. 3 multiply 3, 9. Okay, 9 plus 1 multiply minus 2 to give us minus 2 plus 0 multiply 1 to give us 0. Next row, 1 to 1. So let's go. 1 multiply 3 to give us 3. 2 multiply minus 2 to give us minus 4. 1 multiply 1 to give us 1. Let's go now. The last row, which is 1, 4, 2. 1 multiply 3 gives us 3. 4 multiply minus 2 gives us minus 8. And 2 multiply 1 gives us 2. As simple as this. So let's go without wasting time. AB becomes, now 6 plus 4 plus 0 gives us 10. 2 plus 8 plus 1 gives us 11. 2 plus 16 plus 2 gives us 20. Sorry, 20. Next row. Now we have a negative 3 here. Minus 3 plus 2 gives us minus 1. And minus 1 plus 0 gives us minus 1. Now, minus 1 plus 4 gives us minus 3. Sorry, minus 1 plus 4 gives us 3. And 3 plus 0 gives us 3. Minus 1 plus 8 gives us 7. And 7 plus 0 gives us 7. Now we have two signs here, plus and minus. So what do you multiply them? Now plus times minus gives us minus. So we have 9 minus 2 plus 0. And 9 minus 2 gives us 7. And 7 plus 0 gives us 7. Now we have two signs also here, plus and minus. So plus times minus gives us minus. What do we have? 3 minus 4 gives us minus 1. And minus 1 plus 1 gives us 0. Okay, last we have, again, plus times minus gives us minus. So 3 minus 8 gives us minus 5. And minus 5 plus 2 gives us what? Minus 3. So this is how you solve problems or determinants when you are working. Sorry, I said determinants on multiplication of matrices when you are working with 3 by 3 matrices. Alright. So it's as simple as this. It's as simple as this. So the last part, like I said, we are going to be having revisions of our own transpositions. Our own transpositions. Alright. So let's see what we can do. Let's see what we can do. This takes us to example 4. Example 4. Alright. Please share so other students can learn from this class. Alright. Okay, example 4 has to do with transposition of matrice. Let's take a question. The question says, if the matrix of X equal to 1, 4, 2, 3, 1, 3, 6, 1, 8. And matrix Y is equal to 0, 4, 1, 1, 2, 0, 4, 1, 2. Find X plus Y transpose. Now, T there represents our transpose of a matrix. That's the sign for transpose of a matrix. Now, X plus Y transpose. Now, we can't just come here and start transpositing. No, we have to first of all find what is the matrix of X plus Y. So it means we have to add this matrix and this matrix together first before we can find the transposition. Alright, so let's add. I believe we've done addition before. So X plus Y. When we add X plus Y gives us 1 plus 0, 1, 4 plus 4, 8, 2 plus 1, 3. 3 plus 1, 4. 1 plus 2, 3. 3 plus 0, 3. 6 plus 4, 10. 1 plus 1, 2. And 8 plus 2, 10. Now, this is the value, or this is the answer we'll get when we work on X plus Y. But don't forget, the question is actually X plus Y transpose. Now, how do we transpose? It's very simple. Transposing simply means your rows becomes your column. That's all. All your rows becomes column. So if we do that, we're going to have this. My first row here is 183, so it becomes 183 column. Second row is 433, becomes 433. Alright? And then lastly, 10, 2, 10 becomes 10, 2, and 10. This is how you transpose. Your rows becomes your column. So class, this is how we're going to be coming to an end of today's revisions class on matrices involving addition and subtraction, multiplication, and transposition. So we'll meet again in our next class, which has to do with determinants, inverse. Keep on watching Jeff Nano Mathematics class and also keep on sharing our videos. Bye for now.